Hey there, everybody. The purpose of this video is to get you some solutions to this first little exponential quiz here. Just to walk you through it. There's only a few questions that we're going to do. So, first one, it asks, how is it if your interest rate is staying the same, that the amount being added each year is more? Hopefully that makes sense. So even though the interest rate is staying the same, you earn more each year. How can that be? So the big thing you have to think about here is the difference between the exponential stuff that we're looking at right now and all the linear and quadratic stuff that we were looking at. The difference here is that in a linear model, as your independent variables go up by one, by one, by one, by one, your dependent variables also go up by some same number additively. Okay, so up by 2, up by 3, up by 4, add 3, add 3, add 3, add 4, add 4, add 4. The difference here is it's a multiplicative change from step to step. So, for example, to get from year 0 to year 1 here, you're multiplying by 3.6% and adding $36 in the first year. To get from year 1 to year 2, you're multiplying by 3.6% again to get to the next. So you end up adding a bit more than $36 the next year. So we'll see that again. I'm going to crack a spreadsheet open here. We're going to look at it there. But the idea is you are not adding a constant amount to a previous amount. You are multiplying that previous amount by something. Not adding, but multiplying. Okay, and we'll be talking about that in class anyway. I'll walk you through some patterns here. Use them if you want to use them. I wanted to answer the question, how much money will we have in our account after 10 years, assuming 3.6%? So I got a little blank spreadsheet right here. So I'm just going to start. We ran a couple models in class last week. And I'm going to stretch this thing out. Year 0 through 4. We'll go down to, like, I don't know, 23 sounds good. Let's make the whole thing centered. Make it bolded. All right, so years, and it looked like, whoops, the formula you all seem to like, amount in, account. You seem to like this one more than anything. So if we start with $1,000, okay, make that money formatted. You seem to like this one. Take that and multiply it by 1.036. The 1 standing for the $1,000 coming forward, the 0.036 standing for the 3.6% you're adding on. And then there's your $1,036. And then it seemed like you just like dragging it down. Because every time you drag it down, you end up with, let's get these decimals a little bit less. And let's make it make more sense. We don't need tenths of a cent. There, maybe one more. There we go. So each time you drag it down, it's taking 3.6% of the previous amount and knocking it downward. So what I'm going to do here, just to kind of reiterate what we just were talking about, let me do the first differences here. Okay, so this is what we did with linears. So if we do this number minus that number, then drag that puppy down. Notice they're getting bigger each year. There's a pattern. They're getting larger. It's not a linear pattern. It's also not a quadratic pattern, because if it were a quadratic pattern, second differences. I think I spelled both those words wrong. Second differences. I spelled one of those wrong, but that's okay. We can do that minus that, and you'll notice that they're not the same either. They're getting bigger. And the reason the second differences are getting bigger is because the first differences are getting bigger faster the further you go down. So it's not about differences. It's not about first, second, third, fourth, fifth. It's not about differences. It's about first quotients or products, depending on how you want to look at it. You all in class have been doing it both ways. First, quotients. So let's look at what happens if we take this year divided by the first year. Not subtract the first year, divide by the first year. Hopefully 1.036 makes sense. And they're all going to be 1.036 because that was how we set up the idea of earning interest in your bank account. So the reason that this stuff is exponential is because of these first quotients. So anyway, the big answer to the question was, how much do you have in your account in 10 years? And that is right here, about $14,025-ish, somewhere in that neighborhood. How long will it take our investment to double? And I said Excel will be handy here if you want to use it. Yeah, let's go back to Excel real quick. We'll take a look at it. So it's going to go from 1,000 to 2,000. Looks like it happened right about the year, somewhere around 19 to 20. somewhere closer to 20 than 19, I guess, but definitely around that in that general area. Okay. Let's see. Google the rule of 72. Yeah, I've never Googled this in a while. Rule of 72. Let's see what it says. I know what it says, but Investopedia. The rule of 72 is a quick, useful formula that is popularly used to estimate the number of years required to double the invested money at a given annual rate of return. Okay, so all you got to do. Where's it? Talk about the shortcut somewhere in here. Man, oh, here we go. Years required to double an investment is equal to 72 divided by the compound's annual interest rate. This is over here compounding interest, because you're taking what you earn and reinvesting it and then applying the interest to the total every time. You're reinvesting the money. So what the rule of 72 says is just take the number 72 and divide it by the number 3.6, not 0.036, but the actual percent, 3.6, and that'll tell you roughly how many years it would take, which is exactly what we found down here. It relates perfectly. It tells us roughly. A few of you on your quiz were surprised by this and said, wait, why does that work? I encourage you to ask me in class or at break or something like that, and we'll chat about why the rule of 72 is the rule of 72, and also what rule would it take to figure out how long it takes to triple? What would the rule be then? So anyway, we can chat more about that in class, but I just wanted to get you these solutions to the quiz. Hope they helped, and we'll see you in class.